Okay, get this. What if an AI could do more than just crunch numbers? I mean, what if it could come up with its own hypothesis, run the experiments, and then write a whole scientific paper about it? And what if that paper was actually good enough to get past human experts in a peer review? Well, we're going to dive right into that because this isn't science fiction anymore. It just happened.
Yep, researchers over at Sakana AI have built a system that did exactly that. And this is a big deal. For the first time ever, a paper that was written from start to finish by an AI with zero human hands touching the content was accepted at a peer-reviewed scientific workshop.
And, the team that built it called this a landmark moment, and you can totally see why. This quote right here, this single sentence, it marks a huge milestone for AI in the world of science. This is a genuine breakthrough that, honestly, could completely change how we make discoveries.
So the million-dollar question is, how did they actually pull this off? I mean, how do you even begin to build an AI that can copy the entire scientific process from the first idea to the final paper? Well, to get that, we need to meet the machine that wrote the manuscript. This is it. It's called the AI Scientist, version 2. We're talking about a completely autonomous system that handles the entire research pipeline. But, to really appreciate what a huge leap forward V2 is, we got to take a quick look back at what was wrong with version 1.
So the first version, look, it was a really big step, for sure. But it wasn't truly autonomous. It was more like an AI assistant on training wheels. It needed a lot of human help to get going and to stay on the right path.
Basically, version 1 had two huge roadblocks. First off, it needed human-made code templates. That means a person literally had to sit down and write a starting script for every single new research topic, a huge bottleneck. And second, its approach was totally linear. It had a one-track mind, It could only test one idea at a time, which really limited its ability to dig deep into complex scientific questions. So the researchers knew they had to fix this. They went back to the drawing board with two big goals: make the system truly independent and turn it into a much more powerful explorer of ideas. And their solution was to build a completely new architecture from the ground up. And this is the upgrade. Version 2 is what's called Domain General. That's a fancy way of saying it doesn't need any of those human-made templates anymore. It can just start from scratch, all on its own. And instead of that rigid one-idea-at-a-time process, it uses this incredibly powerful new method called agentic tree search.
So, what in the world is agentic tree search? The best way to think about it is with an analogy. Imagine version 1 was like a single chef trying to perfect a recipe by changing just one ingredient at a time. Super slow, right? Well, version 2 is like a whole team of chefs in a massive kitchen, all testing dozens of recipe variations at the same time. A little more spice here, a different cooking temp there. That's agentic tree search. The AI explores thousands of possibilities all at once, in parallel, and it learns from all the dead ends to quickly zero in on the most promising ideas. And to keep all of this from becoming total chaos, the whole process is managed by an agent, and it guides the AI through 4 stages, pretty much the same way a human researcher would work. It starts with a preliminary look-see, then it does what's called hyperparameter tuning, which is just a nerdy way of saying it fine-tunes all the tiny little settings. After that, it executes the main research plan. And finally, it does ablation studies. Again, fancy term for just removing parts of its model one by one to figure out which pieces are actually doing the important work. Okay, so the system is built. It's powerful, it's autonomous, but that's all just theory, right? Here's the real test. Can it actually do real science? Can it produce something valuable? To find out, the researchers put it up against the ultimate test for any scientist: formal peer review. So here's what they did. They had the AI Scientist V2 generate 3 complete research papers. And when I say complete, I mean from absolute scratch. No human edited the code, the results, the charts, not a single word of the text. Then they took these 3 papers and submitted them to a workshop at one of the biggest machine learning conferences, ICLR. And one of them got in. It actually passed peer review. The paper received an average score of 6.33 out of 10 from the human reviewers. Now, to be clear, this wasn't some kind of pity pass. That score actually put it in the top 45% of all the papers submitted to that workshop. It was legitimately competitive. So you're probably wondering, what was this historic AI-written paper about? Well, it was investigating a new technique to help neural networks learn better. But here's the really fascinating part. The AI's main conclusion was that its own cool idea didn't really work. In science, we call this a negative result. And that might sound bad, but it's actually incredibly valuable. Why? Because it tells the rest of the research community, hey,
Don't waste your time going down this path. We already checked it out.
And the human reviewers totally picked up on that. One of them even said that the core idea itself was interesting. Now that's really important, because it shows the AI wasn't just, throwing random spaghetti at the wall to see what sticks. It was coming up with concepts that actual human experts found intriguing and worth thinking about.
But, and this is almost as important, just like any paper written by a person, it wasn't perfect. That same reviewer pointed out that the paper really needed a better explanation for why the idea should have worked in the first place. And that is exactly the kind of critical, constructive feedback you see in peer review all the time. The AI's work was good enough and, flawed enough to be treated just like a paper from any human researcher.
So look, this is a landmark achievement. There's just no doubt about it. But the creators themselves are being really clear-eyed about where the tech is today and about the huge questions this whole thing raises for the future of science.
Okay, so let's be real about the limitations here. Remember, only one of the 3 papers actually got in, and it was accepted to a workshop, not a top-tier main conference, which generally have tougher standards. And right now, the system is much better at digging into existing ideas than it is at generating those truly novel, earth-shattering hypotheses, at least for now.
And this next part is maybe the most important piece of the whole story. The researchers handled this experiment with so much care. They got full ethical approval, they told the reviewers up front that some papers might be from an AI and gave them the chance to opt out. And, get this, after the paper was accepted, they withdrew it. Their goal was never to sneak an AI paper into the official scientific records. The whole point was to kickstart a transparent public conversation about how we, as a community, are going to handle this powerful new reality.
And that brings us to the final, critical question. Look, the AI scientist isn't perfect yet. But this experiment? This feels like the starting gun for a whole new era. The path forward seems pretty clear. As these systems get exponentially better and more powerful, we have to start asking ourselves a really profound question. When an AI helps cure a disease or completely changes our understanding of the universe, is it going to matter who or maybe what made the discovery?